The tyrosine is a kind of a bactericidal agent. So we use that and then forming a coating layer so they can kind of kill bacteria. So it's use a kind of antiseptic purpose of that membrane. So we cooperate with the doctor, and then he used that kind of technology in tooth printing. And also we use the complex nanoion nanoparticle for bacteria disinfection. Okay, so we use that particle and then with a very small amount of hydrogen peroxide. In that bacteria inhibition, we use the smoke condensed liquid. As I mentioned, we got the liquid from smothering the fruit tree branch. Okay, and then the fruit tree branch, we actually burn it, but because in environmental engineering, if we burn something, we will produce the pollutant substance in the air. To avoid that, we actually condense that smoke through a condenser, condense the liquid. And we think the liquid, we analyze the liquid composition, okay? And then the composition is mostly phenolic-like substance. And this kind of substance, we actually tested for bacteria inhibition and for mosquito larvae inhibition. And it works quite well. Actually, we are using that at a very small dosage, and then we can get 100% cure of the mosquito larva. And the reason we're doing this kind of research is that in Kaohsiung city, that the city I'm in, we have a lot of problem about mosquito. So hopefully we can use this kind of technology to prevent the growth of the larvae of the mosquito. We got quite a few patents about it. We find out that the heme is able to, the hemoglobin catalytic structure, that's the hemming part. This structure can actually direct the electron and become oxidation and reduction state. Second part is that because we're doing catalytic oxidation, okay, mediated by the ion, is generally known as the Fenton-like reaction. But most Fenton-like reaction has to be operating at a very low, and then, but using heme and another material, we discovered EDTA ion. Actually, we can provoke the Fenton-like reaction at a neutral pH, and even better at alkaline pH. And in the soil treatment, we have to spend a lot of money to buy the acidic material to acidify the soil if we want to do the Fenton reaction. So it's not really economical way of doing so. So that's like the catalyst we have. Actually, we can perform the treatment in a neutral or even at alkaline condition. The first one, we use anaerobic digestion method to provide electron. And then electron will kind of dechlorinated the pentachlorophenol into tetra, into tri, and di, and monochlorophenol. So we published this work also in the journal article. And we also talking about the co-treatment of the dying wastewater here using the light-driven oxidation and biodegradation. In Taiwan, we use a lot of very special dye to dye the artificial fiber, because in the artificial fiber, the typical dye, like the acid dye or the reactive dye. So in this treatment, what we do is that we use the oxidation, catalytic oxidation, to break that complex dye first into small molecule, and then we use biological way to clean up all the rest of the dye. And then we also working on some kind of pellets, okay, to treat the contaminated groundwater. Okay, so in environmental pollution, sometimes the pollutants will go very deep into the soil and reach the groundwater. So what we do is that we want to create a microbial phase in the groundwater so that the bacteria can survive in that kind of something like a microsphere environment, so they can degrade those pollutants. We try two things. We degrade total petroleum hydrocarbon in the contaminated groundwater, and we also try to remove the tetrachloroethylene. TCE is a carcinogen substance in the groundwater, and then both contamination actually is very serious phenomena in Taiwan. And the very last one is because our school is surrounded by farmland, so we have a request from farmers to help them out to processing the agricultural waste, and also help them out to try to monitor if their product is safe to eat. To set up a testing and inspection center, and then try to kind of just take some testing of the product from time to time to see if they have any residue of pesticide or heavy metal in their products. Okay, and the other thing is that we do have a lot of farmers. They're talking about they have a problem in terms of the wastes. Okay, and then the most kind of wastes we are working on for now, they cut a lot of the branches out of the tree, but the government right now is prohibit the farmer to burn those branches because they will create the air pollution. So the way we propose them to do is that we combust the branches in a cross system, and then the smoke will be condensed into liquid. That's what I call it, smoke condensed liquid previously. And then we can also produce biochar, something like that. And we can use those two ingredients back to the farmland for planting stuff.